Okay, grade 9 math. This is Thursday, March 12th. Obviously, I'm Miss Stone and I'm not here today. You've got Mr. Bridge and here to present this video to you. Hopefully by now you've done this. You've done your warm-up card and you've handed that into Mr. Bridge and we can check that complete. We are going to do the lesson and I'm going to ask that you take the video, and I'll remind you in the video that Mr. Bridge knows that if you don't pay attention and you aren't polite during the video, that I'll be finding you at lunch tomorrow for detention. Okay, so please pay close attention, make sure you get the note down, try the questions in the exit card, and yeah, work hard, be good. Okay. So here's the note, and I am going to encourage you to ask Mr. Bridge to pause if I start flipping through faster than you can keep up with. The other thing, and I know you're writing this right now, is I am going to get you to use the Desmos today. If you've got your device or an iPad with it. If you don't, it's not the end of the world. But you'll definitely have way more opportunities to learn it. And then you'll just watch me go through the exercise, and maybe you don't do it yourself, which is totally good. When it comes time to learn it yourself, I will help you at that time. But yeah, our goal for today is to use this thing called slope and find slope, and it's like the grade 9 topic, grade 9 math, find slope. So it's a big lesson actually, but it is the exercise that we'll be doing for the rest of this unit. It's probably every single lesson that we do for the rest of this unit will involve finding slope, okay, just in different circumstances. So the language that we're using, I use the word rise and run, and then there's the slope part. So first of all, when I say rise, what I mean is how much a line goes up by, and I'm going to flip to the Desmos in a sec, and you can as well, and we can play with this, okay? Run is how much a line goes across by. And the slope is how steep a line is. So a lower number for slope means it's not as steep. And a really high number means it's a very steep. And you know, when I think of slope from a practical point of view, I often think of like a roof on a house. So if you drove by my house, 75 Mowat, don't egg it, but you can come, drive by if you like, ride your bicycle by, you'd see I have a really, really steep roof, right? So if I was going to measure the slope, it would be a high number. The school, for example, has a zero slope roof. It's a flat roof. So it's completely flat, so therefore it has a slope of 0. And that would be sort of a range of numbers. So getting back to this rise and run business, because it is the idea for the day, I'm going to jump to Desmos right now, and you can open up yours. Maybe Mr. Bridge will pause just while you open up your Desmos, and I'm going to jump to the Desmos on the internet here. So just if you're on the internet, by the way, I just find it by hitting Desmos and Desmos Graphing Calculator. So it's an internet website as well as it is an app. I just like the app so you don't have to depend on the internet. So I'm going to graph a line here, and we'll talk about formats of equations and all that. We have a little bit already, but say I graphed y equals 3x. So here's a line. If I was going to graph another one, y equals 2x. Oops. It's a little, this blue line would be a little less steep than this one, right? So this red one has more of a slope. What if I did y equals a small number, 0.5x? And there it's even. So numbers that are closer to 0 have a less of a steep slope, and numbers that are high, like 3, or we could do 10, right? Y equals 10x, and you can play with this yourself, right? The steeper the number, the higher the slope. So go ahead and play with that for a minute, and then you can pause it if you want right now, but I'm just going to show something else here. Y equals minus 3x. See how it changed direction? Let's just look at this. Y equals plus 3x. So when I have the minus sign, right, it comes down like this. I call that's a negative slope. And this orange one is a positive slope. So the terms, and again, you can keep playing with that, but I'm just going to talk a little bit about rise and run. The terms rise and run on here, they mean, like if I look at this, I'm just going to get rid of this one, and I'm just have the orange line. And again, if you want to pause until you're done playing with the slope numbers, that's okay. And then, but now I need your attention up, looking at rise and run, okay? Because in the note, I'm just going to jump to the note, I mentioned rise, how much a line goes up by. Well, how you see that is, like you pretend, for example, you can just pick arbitrarily, which means you can pick any ones you want. You pick any 2 points on your graph. And so say I picked this one sort of right there, 0, 0, and I picked another one right there, which would be 2 and 6. So between those 2 points, the rise, how much it goes up, is 6, because it goes from 0 all the way up to 6, and that would be the rise. The run is how much it goes side to side, and that's from, because this is my point, right here. So my run is how much it goes this way, which is 2. So the rise is 6, the run is 2, and when I calculate slope, and I'm just going to talk this through, because you'll see examples soon enough, but if the rise is 6 and the run is 2, if you look at your page, it says the slope is rise over run, which would be 6 over 2, which is 3. So when you're graphing a line, the number, you write y equals, and you put some number in front of the x. That number in front of the x is the steepness of it. So I'm going to jump out of the Desmos now, back to our note, okay? So if you get your attention back to the note here, and again, if you need to pause, please do, but I'm moving on. So here's a more manual, and sort of my goal with this whole unit then is to be able to show you things sort of what I call algebraically, which means using letters and numbers, show you things using a graph like that we draw, and then show you things, you know, on the Desmos where it's a little bit easier and you can play with things a little bit faster. And so we're going to look at those three, sort of focus from those 3 areas. So I drew a line here, and again, you might want to pause the tape, Mr. Bridgen, so the students can copy my scale. Okay, be very, you know, notice the fact that on this side, I made 2 blocks a 1. You know what I mean? I'm jumping 1, 2, 3, and then here it's like every block is 1, and I kind of chose that on purpose because there is an important point I want to get across or make you aware of. Okay, so yeah, pause the tape and then ask the students to copy this out as close as they can, okay? And I'm going to assume that you've now paused the tape, you've got everything written down that I have written down, and we're going to calculate the slope of this line. Okay, so if I was going to do it now without the Desmos, just with my hands, my brain, I would pick, you pick 2 points that cross nicely. So like, see how right there, it crosses sort of, I can easily find the coordinates of that point, right? And here, oh, anything that has a 0 in it's nice. So you choose 2 points that cross nicely, and I might label those points. I might write, so the 1 point is 0 and 6, right? It's this point right here. And then I'll label the other point. Over here, this purple point here won't be 0 and 6 anymore. It will be, and I know you guys are good at labeling points, it will be, what is that, 4.5? We can do that, why not? And 10, 11, 12. Okay, so all I've done here is I've said, oh, not 6, 5, sorry. If someone caught that, Mr. Bridge, write that down and I'll give them a chocolate tomorrow. So that's 5, right? Because it's 0 on the x, and then 2, 4, and that's right between 5 and 6, okay? So I found 2 points on my line. The fact that that one has a decimal doesn't matter. It doesn't matter at all. And then, you know, you don't have to do this, but it's nice to draw almost a little triangle. like a right angle triangle, and I say, because this is how much the run part is, and this is how much the rise is. So the run equals, so you just see how far it's gone over. It's gone from 0 to 4.5, so that's my run. The run is how much it goes across by, right? So you pick 2 points, and you figure out how far it goes across by, and then you say, well, how much does it go up? And that's the rise. Rise equals, so it started here at 5, and it went up to 11, right? So 5 to 11, so the rise must be 6. Okay, so what that tells me then, if I want to calculate slope, it's rise over run. So the rise is 6, and the run is 4.5. And usually you calculate that. You say, what's 6 divided by 4.5? And actually, now that you're using Desmos, that's a great choice for your calculator. I can actually do that divide in Desmos too. So you might need to pause, but I'm just going to jump over to Desmos here and go 6 by 4.5 equals 1.3. So well, I'm going to round it to 1.3. You could leave it. Best to put it in lowest terms, like without a decimal, but 1.3 is fine. So the slope of this equals 1.3. And if you remember this from, I don't know if you remember this, but you can always put a dot over top of the 3 to say it's 1.3 repeated. And that's it. Okay, so that's calculating the slope of this line. So again, to recap, you pick any 2 points you want, and it's nice just to pick ones that cross on the grid, okay? You figure out how far it goes across in that time, which is the run, which in this case is 4.5, and how much it goes up by in that time. So I'm moving on. So down here when it says a symbol for slope is m. So we always use, you might, yesterday's note we talked about y equals mx plus b, and we said m was the constant, or the constant variation. Well, we won't use this term really anymore. It's there, it's real, but we always just say slope or m. Okay, so the m represents the slope. And so this is our big equation for the year, for the semester. Okay, so moving on, again, pause if you need to. So just a quick thing on a positive and negative slope, and we saw that in the Desmos. I'm going to jump over, okay? So to remind you, I'm just going to get rid of this. There's y equals 3x. If I did y equals negative 3x, it would look like this. So what I want you to remember, and this is what we're going to write on the note, we're just going to draw a line that looks like this for a negative slope and looks like that for a positive slope. So let's just go back and do that. So a positive slope will look like something like that, okay? And a negative slope will look something like that. So that's the difference between a positive and a negative slope. Very common to forget that. Okay, so next we're going to do an example here of determining the slope of this cliff. And in this one it's weird, it's not a graph, but I mean, like I said, my roof has a slope. I actually have not calculated it, but in this cliff example, we see here, this must be the run. It's how far it goes across. So the run in this case is going to be 5 meters, and you can just write 5 is fine. And the rise is going to be 8. So the slope, m then, must be 8 divided by 5. And you know what? I think it's best, because 8 divided by 5 is not a nice number. It's totally fine to leave slopes as fractions. So that's the answer I would leave, 8 over 5. Okay? Rise over run. Which leads me to another little interesting thought playing with the Desmos here. If you put fractions in for slopes, which you can, 8 over 5, right? And it doesn't make sense. It looks like 0. Let's delete it. Y equals 8. Oh, I forgot to put the x. 8 over 5x. There's that slope. Now let's do something different. Let's do another fraction, but what if we did 5 over 8 and compare the two? So this is a fraction where you have a bigger number on top, it's more steep. Where you have the smaller number on top, it's more shallow. Let's do that again. Let's do that again. So what if we said 3 over 2x? 3 over 2, oops. You go divide. And now let's do y equals 2 over 3x. I'm hitting the divide button. Okay, again, 3 over 2 is more steep than 2 over 3. Okay? You can play with a few more of those if you want, but get the idea that the bigger the numerator, if it's a fraction slope, the like, not the bigger the numerator, but if you flip like that, the 3 over 2 is greater than 1. It's a steeper slope. Again, play for a bit if you like, and then you can come back to the lesson here. I'm going to stop this video, and we're going to do a second video to finish this lesson. So yeah, I'll just pause right here.